Everyone, I'm going to start covering chapter 7 for you. Chapter 7 is talking about the sampling distribution of X bar, or simple random sampling. Before they start talking about the sample selection and simple random sampling, they review the statistical inference that we covered back in chapter 1. I just want to remind you of the statistical inference, which is the same as sampling. In statistical inference, what we do, we calculate the X bar, which is the sample mean. This is for sample. We calculate the X bar, we calculate the standard deviation, and we calculate the sample proportion, which is shown by lowercase p bar. We calculate these three measures in order to find those of the population. So these are the measures for the population in lowercase sigma, which is standard deviation for the population, and population proportion. In these three called point estimators, and these three called population parameters, if you guys remember. After they talk about the definition of the sample and the population and all that, then they concentrate on, at the first part of the chapter 7, on sample selection process. When we are going to select the sample, by the way, if you guys follow this video along with the PowerPoint, the old PowerPoint for chapter 7, I think that is going to be a lot more effective for you guys. So I'm on slide number 5. That they're talking about finite and infinite population. When we are going to select our sample, it's very important that we show unbiasedness. To the degree that we show unbiasedness, to that degree our statistical research is credible and is valid. When we are going to select our sample, we normally deal with two type of population: finite population and infinite population. For the example of the finite population is like a list of the students, list of the companies, and it's easier to try to be unbiased with the finite population. The reason there are two methods that we're going to learn in chapter 7, that these two methods they show us how to be as unbiased as we can be when we're going to select our sample from finite population. When we are dealing with the infinite population, it's really hard to try to be unbiased. And in most cases in this course, in this chapter, we are basically dealing with infinite population. And the sample selection should be as unbiased as it could be, but we have no specific ways to make sure that we are going to be unbiased when we are selecting our sample from an infinite population. In order to distinguish between the finite and infinite population, the finite population, we always know the population size. Example, from a population of 500 students, 150 was selected, and so on and so forth. For the infinite population, this is the example of the infinite population. From a population, a sample of 50 was selected. Or from a large population, so we do not know the size of the population. This is one way to identify whether the population we're dealing with is the finite or infinite. When we are going to select our sample from a finite population, the book is offering two methods. One is using the random number table of chapter 7, which is on page 269 for 11th edition users and page 302 for 12th edition users. I don't have the page number for the 13th edition users, but it is table 7.1. This is the table that we have to use when we are going to select our samples to be unbiased. This is called a random number table. This is one method. The other method is using a command in Excel called the rand between command. The way that we are using this table, random number table, is by let me give you an example to show you how we have to use this random number table. Let's say that we are going to pick a sample of 10 from a population of 500, okay? The first thing that we have to do is we have to assign number to our 500 populations. For example, we have to go ahead and start giving the number to 500 students or employees or companies, whatever. We start from 1 and we end all the way to what? To 500. We have a student number 1, 2, 3, 4, 5, 6, 7, 8, all the way to 500. All right? Then we go to the table and start picking 3-digit number, because our largest value in a population is made of 3 digits. But these 3-digit number should be picked in a certain way from the table. Tables are, well, let me use the table to show you. This is going to be a lot easier. So, as you see in here, tables, the data and numbers are arranged in the table. In column, we have 10 columns, and we have 25 rows, okay? We're supposed to pick our sample numbers randomly from this table. How? We have to start from a certain column at a certain row. But who says what column to start and what row to start from? That should come from some people that are not involved with the statistical studies. So we ask somebody for the columns that we have to start picking the number. We ask somebody to give us a number between 1 and 10 for our column. Let's say that they tell us start from column number 2. So this is column number 2. And then we ask them to give us a number between 1 and 25. Let's say that they give us number 10. So that means row 10, column 2, is going to be this number right here, which is 36100. All right? So after we find out from what column, what row we should start picking our numbers, then our numbers should be picked 3-digit at a time. Why? Because the largest number in our population is made of 3 digits. Okay? Now, when we are picking these numbers, there are 2 approaches. One is called with replacement, the other one is called without replacement. The method that we use and is very popular is called without replacement. In without replacement method, when we are picking our numbers, if a number is being repeated, we eliminate the second number. We only pick one of any number. Like if 125 has been repeated twice, we get to the column that we pick two 125, we have to cancel, we have to eliminate one. This method is called without replacement. If we keep those numbers, like two of the same number, that method is called with replacement. 99% of the time, without replacement is used in industry. Okay? And also, when we are picking our numbers, if a number, for example, is like 505, so we cannot have 505 because our range is starting from 1 and the maximum number is 500. Now let's say that we have to go and start picking our numbers from this random number table. I'm going to read it out to you guys. The first number is 3 digits at a time. 361. There are 2 zeros. We're not going to, of course, use those 2 zeros because we only pick 3 digits at a time. 361 is going to be one of our samples. 003 is the next number. That's going to be another sample. That's 2. 925, we cannot have 925 because that's out of range. That's larger than 500. Next number is 456. We can have 456. Next one is 835. We cannot have 835. Next one is 376. We can have 376. Next one is 360. We continue going across until we finish collecting our 10 samples. And in this process, if a number is being picked twice, we're going to go ahead and eliminate one of them, and this is called without replacement method. The other method is using the rand between function in Excel. In an example that we have, so you go to the cell and you start using the formula equal rand between, no space in between, and then you open up the parentheses, the smallest number 1, and then comma 500, and then you press enter. They are going to show you a number in a cell, in the cell that you're executing this in, and then you use the autofill and drag down that one cell, like 10 rows. So 10 random number between 1 and 500 are going to be displayed on the screen of Excel, and those 10 are going to be your samples. Now let's go ahead and do problem number 1 and 5 in here. Problem number 1 is on page 272 for 11th edition users, on page 305 for 12th edition users, and on page 311 for 13th edition users. I read it out to you guys. You guys can have the book next to you to make it a lot easier. Number 1, consider a finite population with 5 elements labeled A, B, C, D, E. 10 possible simple random sample of size 2 can be selected. You might think that this is kind of similar to those that we did in chapter 4 and chapter 5, but in here we call it simple random sample. Simple random sample. So problem number 1, we have A, B, C, D, and E. And part A, they want us to show how many combination of 2 of this simple random sample of 2 we can have. So we can have AB, we can have AC, we can have AD, we can have AE, we can have BC, we can have BD, we can have BE, we can have CD, we can have CE, and we can have BE. This is the total of 10. Part B, using simple random sample, what is the probability that each sample of size 2 is selected? So this is the example of the equally likely or classical method. So each one has 1 out of 10 chance to take place. And then part C, assume random number 1 corresponds to A, random number 2 corresponds to B, and so on. List a simple random sample of size 2 that will be selected by using the random digits of 8057532. So what they say in here for part C, they say that you assume that 1 is associated with A, 2 with B, 3 with C, and so on, 4 and 5. And then these numbers are given 8, 0, 5, 7, 5, 3, 2. 8, 0, 5, 7, 5, 3, 2. So they want us to use these numbers that are associated to the letters of alphabet, whichever one of these that is associated with those, then make combination of 2 of them together. We don't have 8, we only have 1 through 5. Forget about that. We don't have 0. 5 is associated with E, so instead of 5 we can put E. We don't have 7. We already used one of the 5s, so it should be 2 of a different kind. Therefore, the 2 that are left in here, 3 or 2. So E for C, I'm sorry, for 3 we use C. So EC, that's E, which is 5, and C, which is 3. You can also do EB, but since